Hello students. In this video I'm going to help you work through the first page of section 9.2, background to solutions. Now in the last section you saw some videos about whether different solutions can conduct electricity and also if different solutions can, or if different substances can dissolve in themselves. So let's talk a little bit about what a solution really is and what it means to dissolve. Let's start by looking at this organizer, which we saw way back, if you remember, way back in the beginning of the year, back when back when you could go outside and see your friends and do lots of fun things. Anyway, that's beside the point. This graph, this organizer shows us different ways that matter, that physical things can be arranged. We've got atoms. We can group atoms together with bonds and make compounds. And we also saw that we can have mixtures. We can have atoms that occupy the same space but are not bonded together. And they can easily be separated. And in fact, we've got different types of mixtures. We've got a homogeneous mixture and a heterogeneous mixture. Well, it turns out that a solution is just another word for a homogeneous mixture. And just a little refresher on that difference. Remember that homogeneous mixtures have all parts looking the same. So the particles in them are distributed uniformly. We don't have two separated parts of that mixture. The mixture fully mixes together so that all parts of the mixture look the same. And remember that that prefix homo means same, and hetero means different. So we have some examples of heterogeneous mixtures here that have kind of some separate parts, like cereal and milk. We know the cereal floats at the top, but in vodka, it all looks the same. And in salt water, also that salt dissolves in water, and the whole mixture looks the same. All right, and this is a common thing that we're actually going to see, is that when we dissolve things in water, this is an example of a solution or a homogeneous mixture. It's not the only type of solution, but it's the main one that we're going to focus on. Okay, so what is a solution? All right, on that first page of your notes paper, go ahead and write this down. It's a homogeneous mixture, which means it's a mixture with uniform composition and evenly distributed parts. So all parts of it look the same. All right, if you want, you can pause the video and write this down. But I'm going to go ahead and move on to a little practice with identifying, is something a solution or not? So all of these are mixtures, but not all of them are solutions. Not all of them are homogeneous mixtures. So go ahead and pause the video for a second and then work on this. And then when you're ready to check your work, come back. Okay, so let's talk about these 8 substances and see, are they solutions? Are they homogeneous mixtures? Oil and water. Well, we actually saw, if you saw the videos in the last section, you saw oil and water, and oil did not dissolve in water. They stayed separated. The oil goes on top of the water. So oily water is not a solution. It's a heterogeneous mixture. What about soda? Do we have something dissolved in water? Do we have all parts looking the same? Yep, we do. So soda is an example of a solution. What about bronze? This is kind of a weird case. Maybe we don't know too much about bronze or alloys, but bronze is a mixture of copper and tin. So while it is a solid, if we look at bronze, all parts of it have a uniform composition. They're at the same ratio of copper and tin. So bronze is a bit of a weird case, but bronze is also a solution, albeit a solid one. Okay, milk, also actually kind of a weird case. I think you can make an argument either way for milk, to be honest, because milk does look pretty uniform. However, if you think about whole milk, real milk, a lot of times there's very fatty parts of it. In fact, sometimes the cream on milk separates and goes to the top. So, and we know that kind of like oil doesn't dissolve in water, those fatty substances and those proteins in milk don't really dissolve in water. So I would argue that milk is a bit more heterogeneous than homogeneous, but milk's a bit in the middle. I think you could make an argument for it either way. I'm going to go ahead and say, though, that it's not a solution for right now. Salt water. Definitely salt dissolves in water. That is an example of a solution. Salad. Well, we've got a mixture of things, but again, we could have those croutons sinking to the bottom. We could have things on top, or we don't have all parts of the salad looking the same, so it is not homogeneous. This is a heterogeneous mixture. Air, again, a weird case because it's a gas, but if we think about air, whether you pull from air on your right or your left or above you or below you, all air has the same ratio of oxygen and nitrogen and other components. So air is a homogeneous mixture. It's a solution because all parts of it have the same composition. Well, Kool-Aid is, again, kind of like salt water and soda. We've dissolved some sugary powder in water, and it fully mixes in with the water so that all parts of it look the same. We have a solution, we have a homogeneous mixture. Okay, so now we have an idea of what a solution is. A solution is basically a homogeneous mixture, and a prime example of that is when something is dissolved in water. All right, now we're going to talk about these words solvent and solute. So, to make a solution, since we're often dissolving things, the solvent is what does the dissolving. It's what dissolves the solute. The solute is what gets dissolved in the solvent. So basically, the solute dissolves in the solvent. All right, so a lot of S words here going on. Takes a bit of practice. Well, we got some practice for you right here with those two new words, solute and solvent. So remember that the solute dissolves in the solvent. So what we want you to do on that next part is, of these 5 solutions, pick the 3 liquid ones and identify the solute and the solvent in each of them. So again, not all these, while these are all solutions, they're not all liquid solutions. So just do the 3 liquid solutions for this part. So pause the video, do that practice, think about it for a minute, and when you're ready, come back. Okay, now I'm not going to go through these in any particular order, but our 3 solutions we had were soda, our 3 liquid solutions, soda, salt water, and Kool-Aid. Those were our 3 liquid solutions from the previous practice. Air and bronze are solid solutions. Okay, so in soda, remember the solute dissolves in the solvent. So what do we dissolve in what to get soda? Well, a couple things, but the main thing that we dissolve in soda is sugar. Okay, if you said CO2, carbon dioxide, that's fine too. There's also some carbon dioxide dissolved in soda. What are we dissolving it in? Water. So basically you take sugar, take CO2, dissolve it in water, that gives you soda. Okay, what about salt water? Well, it's kind of in the name, right? To get salt water, we dissolve salt in water. So salt is our solute and water is our solvent. All right, and then in Kool-Aid, again, we talked about this just in the last slide. We basically are taking this sugary powder, sugar, and we're dissolving it in water. So it turns out that water is actually a really good solvent. And that's part of the reason why it's so important to life, and part of the reason why it's so useful and so unique in a lot of ways. We'll talk about that a bit more. But for right now, just make sure you have these 2 words down, solute and solvent. And again, the solute dissolves in the solvent. Okay, we got some more words for you here. Lots and lots of words. So again, If you need to write them down, pause the video and write them. I'm going to keep it moving now. So we're going to talk a bit more about especially these two words, dissolve and dissociate. And we're going to give you an introduction to them in this video. And afterwards, there's going to be some more resources you can use to explore them. So what dissolve means is the solute, something like salt or sugar or CO2 or whatever, is separating from itself and it interacts with the solvent, usually water, to form a solution. So a lot of us know things that dissolve in water, like salt and sugar often dissolve in water, but we don't really get to see very much what happens at a microscopic level. So I have a picture on the next slide I'll show you in a second. But these two words are connected to this dissolving. So if something can dissolve in water, we're going to call it soluble. So what are some examples of things that are soluble? Okay, salt, sugar, CO2, right? All those things are soluble. They all dissolve in water. What are some things that are insoluble? They don't dissolve in water. Well, a paperclip, a human being. There's a lot of things that don't dissolve in water. Those are some kind of weird examples and silly examples, but you get the idea, right? Well, one last word, this word of dissociate. Okay, this is when a substance actually splits into smaller particles. The substance actually breaks up when it dissolves. So this is a step beyond dissolving. When you dissolve, you separate from yourself, but you stay an intact whole particle. When you dissociate, you're actually splitting up into smaller particles. And an example of this is an ionic solid splitting into ions. So I promised you a picture. Here's that picture, okay? So we got two examples here, salt water and sugar water. Now, both of these things are solutions. They both dissolve in water. They're both homogeneous mixtures. But let's think about dissolving and dissociating. So, well, we're not in class, so we can't discuss with a partner, but turn to your imaginary friend, whoever that might be. Maybe you can think about it with them, talk to your brother, your dog, the chair, okay, whatever. We got to make do with what we have in these weird times, right? So let's look at these two pictures here, okay? Well, it's kind of hard to see, but this is a sugar molecule here. We can see some black carbon atoms and some hydrogen atoms and some oxygen atoms. Now, these sugar molecules are they have separated from themselves and they're interacting with the solvent, with the water in this case, right? Because we have these sugar molecules, they're separated here, but they haven't broken apart into individual atoms. So these sugar molecules, they're dissolving only. They're not dissociating, right? We see still a whole sugar molecule here. Now, if you look at the salt, this is sodium chloride, you can see that, yes, the water is interacting with the different atoms here, so it's dissolving. And in addition to that, it is splitting into smaller particles, right? We see these positive and negative ions, these sodium and these chloride ions, being split apart into individual atoms. So it is splitting into a smaller particle. The compound's actually breaking apart. So this is both dissolving and dissociating. Okay, so that was a brief introduction to solutions and solute and solvent and dissolving and dissociating. There's some more resources on your paper to watch and to read and to practice. But this video is over for now. So, goodbye.